Thanks very much, John. Hello, everyone. Thanks for that introduction, John, and thanks a lot to the iStructE indeed just for the invite to speak to you today and provide this this lecture or this webinar, not sure what we call them now, on permanent works design solutions to reduce temporary works in the context of facade retention schemes. So I'll just start at the beginning and just introduce ourselves a little bit more. So I'm Patrick. I'm Associate Director here at Renaissance, and I'm here with Emily.
Hiya, I'm Emily. I'm a structural engineer at Renaissance as well.
So we've both been fortunate enough to be involved in several interesting schemes in our time here at Renaissance, one of which will form the main basis of this presentation today, which is the Glassworks project in Manchester. But in addition to that, we've been fortunate to deliver a wide range of projects from high-rise frames of a range of different shapes and sizes, such as the Viaducts Phase 1, which is a relatively well-known one, which is built over Grade 2 listed arches. Worked on that together. We've worked on complex refurbishments of listed buildings, such as the printing press project in Manchester, multiple temporary works, design commissions, and just about everything else in between, I think. So, the reason I mention that is really through working on projects such as these, we've over time developed a real kind of passion and enthusiasm and an appetite really for working on really complex projects, multifaceted projects, where particularly close collaboration is needed between not just the design team and different members of the design team, but also the site teams as well. And that being a really key ingredient to the success of these projects. And really this experience really came to the fore in the case study project of Glassworks, which we'll be discussing in quite a bit of detail today. So I'll just briefly kind of touch on a little bit more background on Renaissance, just for those who are not familiar. But we are a civil and structural engineering practice based in Manchester, and we're established sort of 12 to 13 years ago. And in that time, we've grown to around 40 staff now, with a really interesting and wide portfolio of work. So, and I think one of the things that's really quite relevant today for this talk is that whilst probably 80% of our work is permanent works design, we do a significant amount of temporary works design as well. And that, you know, kind of having a bit of a balance of permanent and temporary works design experience was a really key aspect of this project that we're going to talk about. And so that's something that's I think worth kind of raising. So on to the next slide. So just as a bit of a blurb really about the presentation in a bit more detail, the basis of the talk is the reuse of facades and how permanent and temporary works designs interface with facade retention schemes in particular. And picking up on some of John's points, actually, you know, in the context of the climate emergency and our kind of anticipated longer term trend towards more adaptive reuse of existing buildings and urban regeneration in general, I think we can anticipate that the reuse of existing structures and in turn facade retention schemes becomes probably increasingly adopted. And I'm sure we're all aware that the imaginative and innovative reuse of the existing building stock will need to form a key part of achieving net zero ambitions and also preserving heritage assets in the UK as well. So as we'll see in the following slides, facade retention schemes can actually be quite carbon intensive, particularly when using lots of bespoke hot rolled steelwork. And it's important, I think, to acknowledge that. And really what we're hoping to present today is an example of where an appreciation of this alongside some of the more traditional appreciations of things like material costs, that can really influence more innovative design solutions, which can help to save embodied carbon and costs within both permanent and temporary works design as well. So hopefully we can kind of touch on some of those points. Just go to the kind of content slide of the presentation. So this is the running order. So obviously we're doing the introduction. Shortly we'll be delving into a bit more of an overview of the Glassworks project, which is the photograph you can see on the right of the screen here. Followed by a detailed analysis of the site. That's something that's really important in any project, but particularly when we're looking to reuse existing buildings or facades, really getting into the bones of the history and the makeup of that existing building. So we're going to go into that in quite a bit of detail. And then we're going to start to move on to the facade retention scheme design development that we produced, and really walk through that design journey that we went on. And that wasn't always a smooth journey, and we kind of quite open about that. And I think just showing what the initial solution was, how we challenged that really, and how we had to rethink that and a revised, more integrated approach, and where that kind of innovation sort of came from really. And then we've got quite a few photos as well showing the implementation of that on site as well. And then we'll obviously conclude with a bit of a summary and a bit of a thought piece as well in the Q&A. So with that, I will pass over to Emily. Just after this slide, actually, I'll just run through the introduction to this one. So yeah, just before Emily starts, on the site analysis, we just thought it was the correct place to start with an acknowledgement of the team that was involved in this one. This was very much a team effort. Obviously, we're sat here talking about it today, but this was very much a team project, and touching on who's doing what, which is always super important in complex projects. Who's doing what and who isn't doing what. So the image on the right here shows the tower element of the scheme, which was a 17-story new build concrete frame. Just to the right of the lower 6 stories, you can just about see the retained warehouse facade that was formed the facade retention for this scheme. Just extends to the right there, and it just kind of sneaks behind that building in the foreground. So some key facts of the project are listed here. The key ones being that it's a commercial office development with retail and amenity provision at ground floor. The client is Solboy, and the main contractor was Domus Construction. The wider design team was John Matthews Architects as the architect, and Nova Integration were the MEP consultant. And very importantly, the temporary works detailed designer was NK Engineering. So Renaissance on this scheme, we were the permanent works civil and structural engineer. And as part of this, we provided a concept design for the facade retention scheme, but that was designed in detail by others, by NK Engineering. So we've also just put the client brief here because that's quite an important kind of context really to where the design came from. So the brief was, as is typical really for high-end office, the brief was to create a column-free internal office floor plate, which we'll come on to later in the presentation. We did try and challenge that at some points in terms of, can we keep existing columns in the middle of the floor plate, which was apparent in the existing building, and can we sort of move to more of a reuse of the existing building rather than just a facade retention scheme? Unfortunately, the kind of office market at that time was maybe less interested in embodied carbon, I think probably fair to say. And it was very much driven by, no, we need open plan floor plates, and so that was kind of pushed away. But we'll possibly touch on that a little bit later on in the presentation, in a bit of the summary. And we've put design for construction here because that was really absolutely key to the success of the project. That integrated approach and the collaborative approach by every person on that list there. Okay, so now I will hand over to Emily. Sorry about that. To talk about the site analysis.
All right, thanks, Pat. So yeah, I'm going to just briefly introduce the site, the context of the site, some of the constraints that we're dealing with as part of this project. So the development is in the city centre, highlighted in the centre here. So for those of you that know Manchester, it's located in the Northern Quarter. It's near the Arndale Centre, just to the bottom there, and to the left-hand side of the page, that's Shrewd Hill Bus Station, just for a bit of context of where it is. So the building is split into 3 blocks, as you can see. So it's got the tower to the left-hand side of the site, as we're looking now, 17-storey RT frame tower. It's got the facade retention section highlighted in red there in the centre of the site, and then it's got a low-rise section, which we're calling Block C, to the rear of the site, so we're calling the tower A, the facade retention section Block B, and the low-rise section Block C. Just in case we refer to it later, that's how we're kind of defining each of the blocks. The Block C low-rise section essentially was architecturally, the intent was to kind of tie that into the Northern Quarter, where all the buildings are circa sort of 5-6 stories at the back there. So yeah, that's the site, and those are the blocks. Some of the constraints that we can see on the screen just here is you've got Shoot Hill tram line running down the front of the site there. That was quite tricky to work around because it limits access, it limits working with cranes, etc. There's quite limited access on the roads as well. So the primary access to the site was down the back along a road called High Street. And the roads that you access the site are quite narrow. The building encompasses almost the entire building footprint, which is always fun. So it's quite a limited area for lay down and for general construction activities. You've got a fragile party wall to the rear of the site, which you can't really see in this image. There's quite a big level difference across the site. There's existing basements at the front where the tower is, and there's not at the back, so there's quite a big level difference across the site as well. And there's also some existing basements in the neighbouring buildings which projected out into the road. So yeah, there's a lot going on the site and not a lot of space which is put. So I'm just going to briefly touch on the heritage and kind of explore that, because it's quite important for facade retention and kind of building reuse schemes to understand what was on the site before, what it's made of, what the context is, and the kind of sequence of what was built first. So we did a bit of a study into this, and so as with a lot of areas around Manchester, the site was largely sort of undeveloped until sort of 1750, circa Industrial Revolution time. You started to see more houses, and in this part of the site particularly, quite a lot of slum dwellings, which were kind of, as Back Turner Street started to form. Then jumping into, you started to get more retail and commercial spaces along these shops and different things. And then in 1870, there was a collection of warehouses constructed. So you've got the shoe warehouse in the centre of the site, and then there's the bottle works warehouse to the left of the site there. And they were typically sort of masonry, load-bearing structures, sort of typical warehouse structures there. And then in 1930, the central shoe warehouse was demolished, and the bottle works factory to the right-hand side was extended. And that was actually a steel frame structure that was kind of clad in masonry and terracotta. So that's a little bit of the background of kind of where these warehouses that were on the site have come from. Now, as we just touching on some kind of historic photographs, because it's just interesting, isn't it? But so this is Basil Chambers. Now, this is the construction of the basement that we can see in this picture. To the left-hand side where those arrows are, so that blue arrow there is the central kind of bottlework section that was replaced by the steel frame. That's the old original one. And then the bottleworks factory at the back there is that purple arrow. That's again the kind of original 1870s masonry work, low-bearing masonry warehouse there. So yeah, and then at the bottom you can see the sort of front end of the site. Again, these buildings have since been demolished, but you can see the facade kind of continues to the front of the site. So moving on to when our client took ownership of the site, you've got the existing bottlework factory from the 1870s at the front there, and it's pretty dilapidated in terms of the condition. You can see the 1930s section slightly further back that was in a much better condition. So when we went to do a structural survey of these warehouses, we actually couldn't enter the 1870s section. It was in a seriously dangerous condition. The floor plates had pretty much all rotten out, so what you were left with, you can just about see it in these pictures, but it was you know, we didn't go in to get better pictures, but essentially there was no floor plates tying that facade in, so you had sort of the circa 5-storey masonry wall that was unrestrained. So we flagged this quickly to building control, and this had been on their radar as a dangerous building before that. They'd noted quite significant live movements. So in combination with our report, they condemned the building, and it was quite quickly demolished because it was particularly life-threatening. Semi-controversial at the time, because there's obviously quite rightly a drive to retain the heritage and retain the reuse. Unfortunately, this one has been empty for circa 60 years and it was in too poor a condition to be able to save it. However, the extension at the back, the 1930s section, could be saved and could be retained. So that's hence the facade retention section that we ended up with. So this is just the demolition taking place. And then, so this is the condition of the site sort of at stage 2, when concept design began and when we started working through the design with the architect. Now, it was really important for us to understand the condition of that warehouse in as much detail as possible. So we did a lot of surveys, and here's just some sort of quite quickly sketched site notes of one of these. And essentially, we sort of determined the existing load paths, etc., of the building. Now, what we found quite an early example of beam and block floors, which is interesting in this existing warehouse, and that was spanning between a steel frame, as I mentioned earlier. Now, that steel frame was embedded in the facade along the front, so that you had steel columns embedded in terracotta, and that had led to quite a bit of Deansgate disorder, as you quite often see in kind of 1920s, 1930s steel frame at the time. Just the way that they were detailed, kind of steel in contact with the facade led to corrosion, which needed to be repaired. And then, yeah, so you've got the rest of the steel frame. Now, the gable end walls were load-bearing masonry because they predated the steel frame building. They were part of the warehouse that was demolished. So an amount of propping was required, emergency propping essentially to those gable end walls, just to maintain sort of stability in the temporary case. And it was all founded on pad footings, and stability to the frame provided by the external masonry walls, kind of essentially a masonry box. So that's kind of a high-level summary of what was going on with the existing building. So just to summarise, I guess, some of the key site constraints and what we were looking at on this building. So as you've got highlighted in red here, those are the existing basements that we're projecting out onto the roads. You've got fragile party wall structure, you've got the tram, you've got narrow access streets, and you have the facade retention section slap bang in the middle of the site, which is lovely. Essentially there was got a big drive to get the tower going, because obviously a 17-storey tower takes a lot longer to construct from concrete than it will to construct the rest of it. So that was on the critical path. So that needed to be unlocked really before we could do anything else on the site. So that was another kind of constraint for the facade retention section. So yeah, that just kind of gives a bit of a summary of the various constraints on the site. Now, just touching on this one briefly, so at quite an early stage in concept, one option that we explored and put forward to the client was keeping that existing bottleworks factory structure. So instead of a facade retention, keeping the floors and the columns, obviously doing the repairs that were required, and tying in those floor plates. Now, it wasn't adopted by the client or by the architect. It wasn't preferred. The reason for that being that that lots of columns in the floor plate was not considered high-end office scheme, and then also the levels didn't quite align with sort of architectural intent, and you couldn't have steps in the floor plate for accessibility reasons. So yeah, that wasn't taken forward essentially as an option, but it would have saved quite a bit more carbon. So it's always worth pushing for that if you can. So passing back to Pat now to kind of go into some of the design development piece.
Thanks, Emily. That's great. Yeah, so that's a really nice overview of the site and what kind of context we're dealing with the design. So I think I was going to just start this next section really going through the design development of the permanent works and also the temporary works, and how that started really coming out of those site constraints and through the client's brief. So first off with the permanent works design. So we'll just start to describe the key features of that. So as described previously, we've seen the development is broadly split into 3 blocks. From left to right on the screen, you've got the tower element, you've got the central warehouse with facade retention in the middle, and you've got the lower rise bit at the back, which is new build. So, you know, from a purely permanent works perspective, it makes sense to connect all these through together, share a floor plate, share levels, and also share a stability system. So the floor plates are consistent and provide level access and column-free sort of internal office floor space. There are some internal columns around the back of house spaces. The floor plates were formed with in-situ RC flat slabs, which provided a nice clear soffit for the MEP distribution and quite a thin structural zone. And in terms of lateral stability, the tower used the circulation cores as in-situ concrete walls, which were slip-formed, and these walls provided the lateral stability to the tower element of the building. And at lower levels, as this floor plate shows, we also provided almost a gable end shear wall at the extreme end of Block C, just to deal with any torsional effects to stabilise those lower blocks of the building. So quite a relatively straightforward scheme from a permanent works design, really. A nice consistent floor plate, a nice clear legible stability system, and dealing with the site in that way. You can probably just about see in the bottom corner of the screen there the foundation solution. I haven't got a slide here for the foundations, but it was a piled foundation throughout the development. It was the initial scheme. We had piles extending to sandstone bedrock, which was below the site, around 10 to 15 metres below ground level. So a relatively straightforward structural scheme with some interesting features. There were some walking columns to the tower building to deal with some of the changes in the tower footprint as you moved up the building and as you moved above the retained elements. You might also note that the columns within the Block B area where the facade retention was, the permanent columns, you can just kind of see at the bottom there, they are set back in from the facade slightly at this upper level. That's due to the facade changing in thickness as you come up the building. So those columns are planned to be tight to the facade in the basement. But as you come up the building and the facade thins out and the sort of the inside face of that facade steps back, you do kind of get this gap between behind the back of the column. So there's a little bit of a compromise there. But generally, you know, meeting the client's brief and ticking all the boxes in that regard. So with that as a starting point, we started to look at the temporary works solution and really trying to develop that in tandem with the permanent works. At this point, it's probably worth just mentioning one of the key resources. We've got a bit of a list of resources towards the end of the presentation. But one of the really key ones is the Syria guide, the C579, which is the best practice guide for the retention of masonry facades. So that's super concise, really well written. It's a great resource, and it's essentially what was followed in this project. And it's quite prescriptive in terms of what the permanent works designer should do in terms of concept design on the temporary works and when they should do it. So that was what was followed here. So the image on the screen, that's kind of the first option that we considered, really. A fairly traditional external tower type solution with wailing beams spanning horizontally to grab the facade from the outside. As Emily's described really well, there was a lot of narrow streets in the area. So in order to make this work, we'd have to portalize, do some hot rolled steel at the lower levels and portalize that to allow the highways access still through the site, because that was the main way the contractor was going to feed materials into the site and also remove materials, remove waste. So portalized at the ground floor to keep clear access. Relatively straightforward solution. We did kind of run into some issues though with the site constraints in that obviously with there being such narrow streets, there was very limited space in the surrounding highway. And once you consider the Kentelage requirements at the bottom there to prevent overturning of the frame, there was a significant surcharge being placed at the surface, which caused problems when we looked at the existing basements adjacent, which we got a fair bit of information from by the party wall surveyors, and there were some real concerns there. So the other aspect of this is from a timings point of view, there was a real desire and a need from the contractor to get on site within a certain window. One of the things they really didn't like about this solution was the interfaces with the adjacent building owners and having to get the works agreed with the kind of risk to the basement walls and the process that we'd have had to go through with that solution. Likewise, they didn't really want to interface on the highways front in terms of doing any temporary piling in the road or anything like that. And there was a lot of services and sewers and things in the roads, and not a lot of room at all. So we quickly kind of moved away from this solution as it not really being preferred, and tried to have a look if there was a slightly different variation that we could do that fitted the site a little bit better. So where we got to on that iteration was this system, which is what we kind of adopted really around kind of REBA stage 3. We said this is the way we're going to go. So this is more of an internal facade retention system where all the retention elements are done on the inside of the building. So it's absolutely great from a highways point of view. You know, you're keeping your highways clear. We've removed the interfaces and the surcharge pressures that are going to be induced onto the existing basements with the previous scheme. It can be installed early in the programme as part of an enabling works package, along with some early demolition of the existing building. And that, crucially, as Emily alluded to, released Block A tower to be constructed early in the programme. So you can see there's a plan sort of showing the vertical towers in red, and then some horizontal kind of wailing trusses / beams in blue, with the cantilage in the ground floor in the basement there. So that's kind of where we've progressed to start with. And one of the key things that we recommended was the early procurement of the demolition and RC frame packages with the contractor. Obviously, it's quite congested in there, and you know, with schemes of this complexity, the more input we can get, the better at that stage. So that was a key kind of recommendation that we made at that point in time to the main contractor and the client. And as part of that, and as part of the REBA stage 3 sort of solution, I suppose, we provided just these really kind of thumbnail sketches of the sequence. So appreciate these are probably a little bit small on the screen, but just in terms of what these are trying to allude to in general sequence is across the top, we've got the site enabling works. So that would be the demolition on Block A of the existing structures and the kind of the churning through the made ground to remove obstructions and basically get those areas of the site ready for piling. We would have the early demolition of Block B with the installation of the temporary internal restraint frames, and then moving down to the next row, we'd see there the piling rigs working on Block A to start with, then Block C. Piling rig access to the site was quite a challenge. It's worth maybe just touching on that. So Block A being critical path, that was the first area of the site they wanted to pile. The access to that was off the main street, just to the left of the plans there. It wasn't possible to move the piling rig from A through the site to Zone C, just given the sort of tightly packed nature of the temporary works, and also the level difference. There's about a 2 metre level difference between the Block A end of the site and the Block C. So quite difficult to track the rig kind of across that area. So there was almost 2 kind of separate piling operations happening at each end of the building. And then in order to pile the central element of the site, it would have needed a special access piling rig, which obviously was driving up costs and complexity as well. So that was kind of I suppose, getting out the ground, and then the concrete frameworks would come up sequentially, leaving pockets within them for the facade retention system to sit there, and then be removed and filled in later once the permanent frame was installed. So that was kind of the starting point that we got to. So that's that. You know, went out to the contractor. We got feedback pretty early on, which was great from the rest of the subcontractors and the supply chains. And what we got back in terms of temporary works design fitted the bill. You know, it worked. But as we got into more detail with the subcontractors, we started to get into some, you know, real challenges logistically of how tight everything became. So this image on the screen here is the Revit model of the temporary facade retention system. And it was really spatially constrained for a number of reasons. The vertical towers in the facade retention system had to miss the existing building structure so that they could get put in before the existing building was demolished. They also had to miss the permanent works columns because that had to be installed whilst those towers are still there before they get removed. So it's very, very spatially constrained, and we didn't really end up, and also the fact that we had to pile in and around all that meant that the planned footprint of those temporary work systems had to be really quite reduced. So that really kind of put us into a bit of a tricky spot, really, where we had to introduce quite a lot of hot rolled steel. The temporary works designer had to introduce a lot of hot rolled steel. So there was about 90 tons of hot rolled steel that was needed just to get the stiffness in that system, given the kind of spatial constraints. So that, I mean, 90 tons is quite a bit. I mean, when we got this, we had a look, and it would have probably been nearly sufficient to build the new permanent frame for the building, that kind of amount of material. So that kind of gives an indication of the quantity of steelwork that was required there, with it being so constrained. So obviously, with this being hot rolled as well, and specially fabricated for this use, this would have been a really carbon intensive scheme, to be honest. And we estimated, when we just ran the quick carbon assessments, we would release about 160 tons of embodied carbon into the atmosphere as part of that temporary works scheme, let alone the permanent works. So this slide just demonstrates a little bit spatially how tight this solution was becoming, and how tricky that logistical operation would be for piling in particular. So the image there is the green blocks are the areas reserved for the façade retention system, and the grey blocks is the permanent foundation solution. And the yellow rig there is drawn to scale. So that's a Clem rig. I think if this would have gone forwards much further, I think we'd have probably had to swap for a more special access piling rig, a smaller one. So this really was quite a key decision point in the project, where we really questioned the path we were going down. By this time, we'd had a nice early input from the piling contractor, the frame contractor, and the temporary works designer. And crucially, at this point, there was still enough time in the project to really come all together at that point and collaborate and come up with a more integrated solution. And I think that there's a real kind of value in getting that early input and having that collaborative approach between everybody, and getting that early input and doing that at the right time. And from a permanent works perspective, seeking that input early enough and providing enough information early enough that input can actually be meaningful, was a bit of a lesson learned there. So we started thinking about, is there another way to do this to make it safer, a bit more comfortable with piling, make it much less intensive in terms of material use, and to try and make it cheaper as well, obviously, because the main contractor was under a lot of pressure at this point, as we were. So we had some really good discussions with the main contractor about if there was another way this could be done, perhaps by replanning the demolition work somehow. And we said, okay, let's take that away and just have a bit of a think about how we could reimagine this and see if there's a different way of approaching this scheme, given how spatially constrained we were. So if we could just change the slide deck, please, if that's okay, to the next one. Thanks, GC. So that was our challenge, really. So we got to that point. I think we've gone through the design journey that we got to, and we can start to look at where we started to think about the work sequencing in a bit more of an innovative way, and collaborated with everyone to create a different solution, which was ultimately the one that got implemented on site. So I'll just touch on this briefly, just to introduce the concept, I suppose, and then Emily will go into it a little bit more detail. But yeah, essentially, I think the way to describe the approach that we took in the end was that we really resequenced the works, and basically retained the existing building frame for as long as possible. Did enough demolition of it to allow the new permanent structure to be constructed, in terms of its foundations and columns. And then we actually kind of progressively did a demolition and new build floor install from a top-down kind of demolition sequence and construction and demolition sequence. So in terms of the type of solution where that fits in terms of façade retention, that you can broadly describe it as the reuse of the existing load paths in terms of the method, albeit it had a bit of a twist to it in that there was kind of that top-down element of construction as well. So the image on the slide here sort of tries to convey that as a concept. So if we just kind of move slowly sort of from left to right, we've got the existing warehouse just conceptually drawn as the box there with the floor plates. And then moving to the right, we've got the initial phase, which is the demolition of the gable end walls. And that was crucial to allowing Block A tower to progress. So that was a really key driver. So in order to demolish those gable end walls, rather than put in a full facade retention system, the idea was actually let's keep the existing steel frame that's in there and let's brace that up vertically in a set of temporary vertical bracing to actually kind of replace the stiffness of the gable end shear walls that have gone. So there was some temporary cross bracing installed into the steel frame to enhance it. That then allowed the gable ends to be demolished. So that was the crucial first step. Another key challenge was getting the permanent foundations in at this stage. So the raft foundation then went in for the permanent solution. That then allowed the permanent columns to be installed off the new raft, whilst the existing building frame is still there and still stable. And the existing facade is still tied to the existing frame at this point. We did have to form kind of localized pockets within the floor to allow the columns to come through there. And then the sequence progressed in a top-down fashion from there on, whereby the top story of the new build was installed, tied to the facade, and then the demolition of the floor below it occurred, which is just described in this slide in a little bit of a different way here. There's some sections there that show the interface between the existing floor levels and the proposed ones, which kind of facilitated this top-down approach. And it was almost an unclipping of the existing facade from the demolished floor and clipping it back to the new floor as you came down the building. So it was almost zipping it and unzipping it at the same time as you come down. So I will just hand over to Emily at that point, who can. We've just got some 3D images, which I think just bring that to life in a little bit more detail.
Cheers, Pat. Yeah, so we're going to start just kind of delving into what Pat summarised, but sort of with some graphical imagery to try and sort of break it down a little bit. So yeah, so we've got the current condition, which you can see here, which is the existing warehouse, and as we touched on earlier, is an existing steel frame structure. Now, as part of enabling the demolition of the gable end walls, we put some cross bracing through the existing steel frames to keep that lateral load path and that stability path as close as possible to the existing lateral load path that was there. And that then enabled the gable end walls to be demolished, along with some vertical props of the steel work at the end there as well. That was put in. So there was some hot rolled. There was some temporary works that have gone in, but it wasn't hot rolled this time. It was all proprietary, like slim shear systems that were usable. So from an environmental perspective, it was kind of a much better approach. So then we get into the fun side, which is installing a new raft foundation, or basically installing a new structure around the existing structure. Now, the installation of the raft footing, as Pat's touched on, was quite complex because we needed to install it carefully around the existing pad footings. We also needed to be quite careful because it was an existing basement in there in terms of the stability to the retaining walls, making sure that that was maintained while the raft was replaced. Now, Pat's going to go into a bit more detail in terms of how. In terms of the replacement of that raft and kind of the temporary sequencing that we did for that. But yeah, so gable end walls demolished, new raft in place, and that then enabled the new steelwork frame to be put in. So essentially, pockets were put into the existing floor plates and new steel columns were threaded through, which was quite something to behold, really, as seeing it happen on site, and the kind of close collaboration that was needed between demo contractor, steel frame contractor, and then kind of the main contractor as well. It's quite impressive to see. So the new steel frame's been threaded through to sit on that raft foundation that's been installed. Now, a lot of the beams could also be installed because the levels, as touched on earlier, were different from the existing to the new frame. So the vast majority of the beams could also go in, and the facade restraint beams to tie the facade to that new steel frame that we've just installed. And then what we could do is we could go up and install a new concrete deck at level 5, and then that basically, once that's cured and knitted in and tied into that existing frame, we can demolish the level 5 floor plate, and essentially the load paths have not changed as part of this sequencing. And then, as you can guess, we carried on down the building. So new level 4 plate put in, let it cure, tying the new frame in through those facade ties, and you can get rid of demolish the existing level 4. Now, there were a couple of floor plates which, well, there's I think 1 or 2 floor plates which did collide with the existing proposed. In those cases, columns had to be temporarily braced out, so the buckling lengths in the permanent case weren't ridiculously long to accommodate this. But for the most part, it was kind of done in a hit-miss sequence going down the building. And then you could finish the steel frame, you could complete the bracing systems for the new steel frame, you could finalise all of the facade restraint beams that are going in, and essentially then you've got the new frame supporting the facade, and you can get rid of your temporary works at this point, your temporary bracing, and you can finish off the frame, put in the level 5 terrace, and tidy up the pockets in the floor plates that have had to be left for the existing structure. So that's kind of a high-level summary of the existing load path method that was used. And as you can imagine, huge amount of collaboration between steel frame contractor, concrete frame contractor, demolition contractor. There's a lot going on at once on the site, RC frame contractor in the basement. And it's really getting everybody on board early, as Pat's already touched on, and kind of fostering those kind of strong relationships and commitment to doing it in the best, most logical way, to minimise these temporary works. So this is just quite a neat picture of them installing it on the site. So what you can see here is you've got the existing columns which I've highlighted there, and then you've got your temporary bracing and temporary cross bracing there. And you've got your new columns there, which are highlighted. You probably can't see it once it's been highlighted, so I'll jump back. But yeah, you've got your new columns pocketed in through the frame, and this is just sort of as the new steel frame is being constructed. So now I'll hand you back over to Pat for kind of the impact that had to the permanent frame.
Thanks, Emily. Yes, so big change in the temporary works design. Really interesting sequence, really interesting kind of savings on offer. So back with the kind of permanent frame, a big change to the permanent frame as well. We've touched on it a little bit in the previous slides, but Block B with this revised sequence had to be done in a steel frame. So now all of a sudden, from a permanent works point of view, we've got 3 very much separate buildings. So we've got the Block A tower and the steel frame for Block B, sandwiching the 2 concrete frames. The other key change, as well as just that was the change in the foundation solution. So for Block B to work in that sequence, we had to use a raft foundation rather than a piled foundation, just with the challenges of getting the rigging in and around all that activity. So in terms of the feasibility of that, we did do quite a lot of early stage assessments, just looking at settlements and what kind of settlements we could expect to see with the raft. Obviously, it's in terms of foundations, it's a real mix. We've got the piled foundations for the tower, piled foundations for the zone C at the end there, and the raft foundation in the middle. So we were concerned about how much differential settlement we were going to be kind of realizing between various blocks. But fortunately, and we did do quite a bit of extra SI at that point. to get enough data to do a really detailed settlement assessment. And fortunately, the clay sort of on top of the sandstone was really quite stiff once you got down below the basement level of Block B. So we, through that kind of initial assessment, we were quite comfortable that this could be something that could work and not have, big differentials across the movement joints. So, yeah, so big change to the permanent works. The other one was steel frame, foundations, movement joints between everything. The other one was the stability system. So Zone A is now kind of completely separate from the Zone C at the end there. So we had to totally reimagine the Block C stability system as well. So, it wasn't an easy kind of change on the permanent work side of things, but it was absolutely the right thing to do. And there was just about enough time to kind of capture that as well without impacting program. So we'll kind of just dive into that a little bit more. So this is the steel frame for Block B. So we achieved that kind of open plan office space at the front there. Given the constraints in the shape of the building, really, it was portalized in the kind of up-down direction on the plan there, just because we couldn't get a bay of bracing in architecturally. We could get bracing in the left-right direction, so that was braced up, and we were conscious. We've talked a little bit about the movement joints between the blocks and the vertical differential movements. We're also obviously very conscious of the lateral movements as well, and making sure that movement joint was something that could be detailed and fire stopped appropriately and all the rest of it. So there was a bit of a balancing of the stiffness of all the frames and try and make them as kind of equally stiff as possible, really, laterally as well. So it certainly added quite a few complexities into the permanent work scheme as well as temporary works. This is an image of the raft foundation. The other piece on this is, so there was a large water tank there as well, which obviously increased bearing pressures quite a bit. There's a good bit of weight there. So that all fed into the mix of the settlement assessment. The other thing we did do as well with the steel frame was to use a lightweight concrete for the composite deck floor slabs. So for the steel frame, it was all composite deck on wriggly tin with concrete topping. So we used the lightweight concrete just to try and keep those differential settlements acceptable, basically, and try and make that steel frame as light as possible. Just another piece to touch on the raft as well. I think by this time the contractor had got a bit of a taste for just removing temporary works or kind of trying to simplify things with sequencing. And they asked us to do the raft without kind of traditional whalers going across and sort of flying shores going across to brace the basement walls. So just to recap, this is within the existing basement of Block B, where we're forming the raft foundation, and we're keeping the existing frame in position whilst we're casting the raft. So what we came up with was a sort of a hit and miss method, whereby not too dissimilar to underpinning really, where we would form a strip of the raft at a time, demolish a strip of the existing sort of basement slab that was propping all the basement walls together, and doing that in a hit and miss sequence, such that they didn't need the flying shores across the basement, which would have further hindered access. So that was another little one there, and we left pockets in the raft for the existing internal steel columns to remain until quite late in the program. And just to kind of finish up on the permanent works bits and pieces, this just describes the movement joint strategy, and there was a lot of description of that in the movement and tolerance report, and some careful detailing around the facades. We can just see at the bottom there in the middle the sort of interface between the concrete frame, flat slabs, and the steel frame, and how we tried to keep that floor depth as consistent as possible from an architectural perspective, so that it didn't disturb the M&E distribution to the soffit of the ceiling. And then on the right hand side, we've got some of the sketches of the facade retention kind of tie beam systems and how they fixed into the facade as well. And a little bit more detail here. So one of the sort of challenges with this approach was we had a secondary kind of rail system fixed to the back of the existing facade and tied back to the steel frame. Doing that allowed us to basically tie the old facade into the new steel frame before we'd kind of necessarily cast those floors, and at a different time, basically just allowed the demolition of the existing floors to happen after we'd tied it to the existing frame, because some of the floor levels did clash with each other, so we couldn't just tie it at floor level as you would probably normally do. So there was a slight kind of bespoke solution on that one as well. So that's a bit of a whistle-stop tour, really, but just we'll finish up just with some photos and just a bit of a summary of the key points, really. I think one of the words that we keep kind of coming back to is collaboration, and coming up with a more innovative solution just required, you know, all the right people in the room at the same time. And just that really reflecting a lot on how the permanent works engineer really needs to work in tandem with the temporary works engineer in a really, you know, in a truly collaborative way to really kind of realize the best solution as a whole, and the timings of that, and making sure that the information is produced in the right time, so that those conversations can happen, really. And we'll just flick through some of the images, I think, just to finish up.
Yeah, and I think another important point just to touch on, I guess, is that yeah, sort of in terms of retaining that existing facade and what it meant from a carbon perspective, and what facade retentions typically mean from a carbon perspective, is kind of thinking about what that would look like if we were going through the design process today. I'd like to think that if we were going through this process again, the proposal to keep that existing building rather than just doing a facade retention might have been picked up, and sort of reworking the levels to suit, etc. Because there's a market for low carbon buildings now, whether it's not driven by legislation yet, it's driven by end users, especially for sort of high-end office schemes. We're seeing a lot of that at the minute. So yeah, it's always worth pushing to kind of retain rather than retain the whole building, really. But yeah, and I think generally sort of this project, while it was quite unique and the site constraints were quite unique, the existing load path method isn't that unique. I'm sure a lot of you have seen it before and seen it implemented in different ways. There's no pictures of it here, but we've adopted it before on an 1850s sort of townhouse facade, much smaller scale, but essentially in this townhouse, the internal frame was gutted and a completely new frame was put inside, again to rethink where the levels were. And again, it was kind of at an early stage with the architect. We worked with them to make sure that the new columns and the new footings could be placed away from the existing ones, so that the new frame could be installed carefully around keeping the existing one in before we take the old one out. So it's not kind of reinventing the wheel, but it's just to I guess point out that you know, that it's always worth considering, and it's worth thinking about, as Pat said, it's worth thinking about the temporary works and the sequencing really early, so that you've got time to kind of work through these things as a team. And also it's not to not shy away from doing things in a slightly more unusual way, because you know, you can save quite a lot of material. So yeah, I think that's kind of...
That's great stuff, yeah. And I just to finish up on just some useful resources that were certainly useful for us and continue to be. So the Syria guide that we mentioned before, the Temporary Works Forum is always great for resources, and of course BS 5975, which has been recently updated at the end of last year as well.